Here's a particle P, mass 2m, and moving with speed u when it collides with a particle q, mass km, speed is 3u in the opposite direction, that's that direction. So as a result of the collision, the speeds are both reversed, and the speed of p is halved. So that's u over 2. This one goes this way now, and we'll call it going this way v. We've got to find the speed of q, so we've got to find v. So we're going to have total initial momentum equals total final. And we're also going to have to remember that for momentum, direction matters. I'm going to take that way as being positive. So I've got the mass 2m times velocity u. This is going to be a negative because it goes backwards, minus km times by 3u, and that equals the total final velocity, final momentum, which is 2m times by the velocity u over 2, but it's negative, so I'll put a minus there, and then plus km times by v. So we can now manipulate this. But first off, we can divide through by m, because everything's got m in it, and we're trying to find what v is. So I've got v is here, that 2 cancels that with that 2, so that's minus u. So I add u to both sides, that'll give us 3u minus 3uk equals, that will be kv. And that will give us 3u times 1 minus k. That's what we've got there. And that will equal, well, if I divide that by k, and that equals v. So I find out what v is in terms of u and k. Hence, write down, this should be easy, the range of the possible values of k. Well, u has to be positive, because otherwise it will be negative and it'll be going the wrong way. K here has got to be positive because otherwise we have a negative mass. V's got to be positive, it's going in this direction, and that's the way we decided was positive, and so therefore 1 minus k has got to be bigger than, that's got to be positive, therefore k has got to be less than 1. It can't equal 1, because if it equaled 1, then the velocity would be 0, and it wouldn't have changed direction. Okay, so that's part I done, and now parts 2. Calculate the magnitude of the impulse which Q exerts on P. So I've got P is this one, that's 2m, initially is u, that goes to u over 2, and we've got the impulse going that way, impulse of Q on P, and the impulse equals change in momentum. And don't forget that it's important to remember direction matters. So that is final momentum minus the initial momentum. The final momentum is going that way, so that'll be 2m times by u over 2. And you've got to take away the initial momentum, but since I'm going to be I've taken this way to be positive, I should put it down there, that way is positive, then I'm going to get a negative here, aren't I? I get the mass, which is 2m times by u, but it's minus u, so I put a minus there. So that equals 2's cancel out, mu plus 2mu, that'll be 3mu. That's part 2 done, and then part 3. I'm going to do this one in red. I've got to work out the coefficient of restitution, and it tells me that k is a half. And so we've got E equals separation speed over approach speed. So E equals something over, well, the approach speed, this one's coming at u, this one's coming at 3u, so approach speed is 4u, separation speed It's u over 2, but I've got to work out what this v is. I've just worked out what it is here. V equals 3u times 1 minus, and it says that k is a half. This is 1 minus a half over a half, and that equals 3u, because that's a half, that half will cancel out with that half, so that equals 3u. So our separation speed is half u that way, 3u to the right, so that'd be 3.5u, and so E will equal, the u's cancel out, 3.5 over 4, which is exactly 7 over 8. And that's question 5 done.